All right, hi folks. I'm recording a video for Section 3.5, which is working with inequalities that involve quadratic functions. Now, you probably remember working with inequalities that were linear. So, a linear inequality might be something like 2x plus 5 is less than 15, let's say. You might remember you solved this inequality the same way as you did an equation. The only difference now is we're working with less than or equal to or greater than or equal to. We want to be able to extend that to quadratic functions. So let's take a look at this example. It says the graph of the quadratic function is shown here, and they want us to solve when is f of x greater than 0 and when is f of x less than or equal to 0. All right, well, one thing to keep in mind here is when I see f of x, I can really think of that as y. Remember, f of x and y are interchangeable. So let me think of this as when is the y value greater than 0 and when is the y value less than or equal to 0. All right, well, let's do the first part here, y greater than 0. I'm going to come over to my graph and let me blow this up a little bit to make it a little easier to work with. All right, I want to know when is the y value greater than 0? Well, here are the y values that are greater than 0, right? These are positive y. Down here is negative y. So I want y greater than 0. So really that's the part of the graph that's above the x-axis. Well, let me highlight in blue the parts of the graph where the y values are greater than 0. So it's here and here. So these parts of the graph that I just highlighted in blue are those parts of the graph that are above the x-axis, which means the corresponding y values are greater than 0. All right, so now it wants me to come up with the answer here in interval notation. So I need to come up with really the x values that correspond to this blue part of the graph. Well, I'm noticing, let me call this maybe part A of the graph, and I'll call this part B. Part A of the graph looks like it's going from negative infinity to negative 6, it looks like. So that's part A. Now I'm going to put parentheses on this because remember we're doing y greater than 0. Okay, let me come over to part B of the graph. So this was part A of the graph. Let me come over to part B of the graph. It looks like there we're going from 3 to infinity. So this part is 3 comma infinity. And then we put a union symbol in between to show that we're joining together these intervals to represent the part of the graph where the y value is greater than 0. Okay. So this was the left portion, and this was the right portion. All right, let me go to part B of this question. Part B says, what about where is it says f of x less than or equal to 0. But I'm really going to think of this as y less than or equal to 0 to make it a little easier to work with the graph. Well, for y less than or equal to 0, that's really the portion of the graph that's below the x-axis. So let me highlight maybe in orange this part of the graph that's below the x-axis. And now I just want to come up with interval notation for that. Well, it looks like it's extending from negative 6 on the left to positive 3 on the right. Now I'm using square brackets because notice it says less than or equal to 0. And the point here, x equal negative 6, is when the y value is equal to 0. So I'm putting a square bracket here because it was a y less than or equal to 0. Okay, so for this kind of a question, I think it's a good idea to really think about f of x rewritten as a y. And then you can ask yourself what part of the graph corresponds to the y values being greater than 0. Well, that's really the part of the graph above the x-axis. what part of the graph corresponds to the y values being less than or equal to 0. That means the part of the graph that's actually on the x-axis or below. All right, let me go to the next example. All right, this one is asking me to use this graph to solve this inequality. And for this one, they're asking me to compare two graphs. There's g of x in red and f of x in blue. So I have the blue parabola as f of x and the red line as g of x. All right, let's go to part A. Part A says, what part of this graph corresponds to g of x being greater than or equal to f of x? Really, for that, they're asking me, where is the red line above the blue line? Right, because if g of x is greater than f of x, it must be that the y values for g of x are above or greater than the y values for f of x. Well, when I look at that, I'm noticing that this part, let me see if I could draw it here. It's going to be from this point to this point. So really, it's this interval where I'm drawing the x interval here. This is the x interval where the red graph is above the blue graph. And if I notice here, it looks like it's going from an x value of -9 on this side to an x value of -3 here. And of course, they want me to write the answer in interval notation. So I'm going to write this as -9, comma, -3. And notice I'm putting this in brackets because this was g of x greater than or equal to f of x. So these points that I'm circling here in red are the points where g of x is equal to f of x, because those are the points of intersection. So I want to include those points of x equal -9 and x equal -3 in the solution to part A, because the inequality symbol is a greater than or equal to. All right, let me go to part B. Part B is asking me, where is f of x greater than g of x? So really what part B is asking me is, where is the blue graph above the red graph? Remember, part A was asking us g of x greater than f of x. So that was really asking us, what part of the graph has the red above the blue? Right, and the red graph above the blue graph. And for that, we already came up with the answer. That was happening on the interval -9 to -3. But what about the other way? What about, where is the blue above the red? Well, let me try to draw this in orange so you can see it. It looks like from this point going back, the blue graph is going to be above. And then from this point going over to the right, the blue graph is above the red graph. So there's two parts to this answer. That left-hand part is going to be -infinity to -9. And the right part is going to be -3 to infinity. And we put a u in between to represent the union of those two intervals. And the reason I'm putting parentheses on the -9 and -3 is this part of the problem said f of x greater than g of x. It didn't say greater than or equal to, it just said greater than. So because of that, I'm using parentheses on these endpoints. All right, let me do another example. All right, let's come to this one. Now, this is solving a quadratic inequality, but instead of using a graph, they're giving me an equation instead. All right, well, you know, there's a couple of ways to do this. One way is if you could sketch out the graph yourself, then this problem would be similar to this problem, right? So for this example, we were able to solve the quadratic inequality just looking at the graph, because we were able to see what part of the graph is above 0, above the x-axis, what part of the graph was below the x-axis. So if I could come up with a similar sketch to this, I'd be able to analyze this problem the same way. All right, well, let me first try to figure out, is this graph opening up or opening down? I know it's a parabola because this is a quadratic function, but is this graph going to open up or open down? Well, you remember the way to tell that is to look at the number in front of x squared. Here, the number in front of x squared is positive. It's a 1. So this graph opens up. All right, so I know that. Also, let me find the x-intercepts for this graph, because if I could find the x-intercept, then I could get a pretty good sketch of what the graph looks like. All right, well, you remember to find x-intercepts, you set the y value equal to 0. So let me go ahead. I'm going to set this equal to 0 and try to solve this equation. This will give me the x-intercepts that I could then plot on the graph. All right, well, let me try to factor the left-hand side. Well, you might notice this is going to factor as x plus 8 times x plus 9. All right, now I'm going to set each one of these parentheses separately equal to 0. So I get x plus 8 equals 0 here, x plus 9 equals 0 here. All right, now I'm going to solve each one of these equations in order to get the x-intercept. So on the left-hand side, I'm going to subtract 8 from both sides. So that's going to give me x equals negative 8. On the right-hand side, I'm going to do the same process. I'm going to subtract 9 from both sides. So when I do that, I'm going to get x equal negative 9. All right, let me sketch this out and see what this looks like. All right, so I know this is a parabola opening up. So here is xy axis. Let me plot these x-intercepts. So I'm going to come over here and plot, here's negative 9, and here's negative 8. I'll exaggerate this a little bit just to make it a little easier to see what's going on here. All right, so here's the x-intercept, here's the y-intercept. I know this parabola opens up. Now, I don't know exactly where the vertex is. I could find the vertex, but I know this graph has to do something like this. It opens up and it goes through these x-intercepts. So I'm going to graph this parabola something like this. All right, well, now I want to know, where is this function less than 0? Right, notice here it says less than 0. Well, that's really asking me what portion of the graph is below the x-axis. Well, it's this part that I'm highlighting in blue. So this part of the graph is the part that's less than 0. But I'm noticing that interval is negative 9, negative 8. And that's really the answer that I need here. And notice, because this is a less than sign, I'm using parentheses on this interval. All right, folks, hope these examples are helpful as you're working in this section dealing with quadratic inequalities.